What's a square root? What does it mean to square root something? Does anyone remember? What's square root? Okay, so I'm going to give you an example here. Let's go with square root of 16. Write these down, guys, because these are your reference. The square root of 16. So what number times itself equals 16? 4. Okay, the square root of 121. What number times itself is 121? It's 11. By the way, when I have the square root symbol, I'm asking what's the principal square root? That means what's the positive number that times itself is going to get me 16? It's 4. What's a positive number that's going to get me 121? It's 11. Because technically, isn't it negative 11 times negative 11, 121? But we're not asking for that when I put this little symbol. Okay, so you guys know what square rooting is, but you need to understand this here, and this is where the lesson is going to take. We're going to have something dealing with our lesson. Square rooting can be undone. It could be reversed. And it can be reversed by squaring. Squaring. Look at that. I got to keep that one for myself. Okay. It's called squaring. Okay. So this is what I want you to do. Let's go with 4. Okay, so that's my original number. I just put a number up on the board. Okay, if I square root it, what would I get? 2. Okay, so you have 2 now. But what happens when I square that? What do I end up with? I end up with 4 again. You know what happened here in this problem? The square root got undone by the squaring. They canceled each other out completely. What else cancels itself out? What cancels addition? Subtraction. What cancels multiplication? Division. Those addition, subtractions, and multiplication divisions are inverse operations. So do you know what squaring and square rooting are? Inverse operations. They undo one another. Let me give you another one here. If I gave you this number, okay, you start off with a number, and I told you, all right, what's that? Some of you may know. Sorry. I think it's 240. I thought it was 2. I think it's 289. That's what's coming up in my head. It is 289. But you may not know that. You can undo that. The way you undo it is by square rooting. So you're like, wait, how does that work? What number times itself is going to get me 17 squared? 17. This undid that. They undo each other. And you're like, well, are you sure about that? Well, what's 17 squared? 289. What's the square root of 289? 17. They undo each other. Why is that important? Seems like just like fun facts. That's going to apply right now. Yes, ma'am.
So how would you say that? Would you say the square cancels the square root?
Squaring or the square cancels the square rooting of that. Yeah, you can say it that way. Or you can say the square rooting is canceled by squaring. Either way, you can go back and forth. They cancel each other out. This lesson, I actually missed a word when I wrote the title. Does anyone know what I missed?
Solve equations by factoring complete. Solve the equations by factoring.
Look, you can look at your book.
Quadratic.
Quadratic. Okay. It was solve quadratic equations by factoring. And that's important because right here, this is not quadratic. What does it mean to be quadratic? Okay, the exponent of the variable at the most is 2. And right now it's 1 and 1. So it's not a quadratic equation, so I'm kind of stuck. But I still want to be able to solve it. And what does it mean to solve? Find out what the variable is. That's not helping me out. I want to undo this square rooting. So I'm going to square it. I'm going to square it. Because what's going to happen with this square root and this squaring? They're going to cancel each other out. But what I do to one side, I have to do to the other. So I'm going to do it to the other. I squared both sides. And then I'm left with, what's x squared? It's x squared. Good. Don't get too deep on that. Good. X squared. And then what's left on the right?
No way.
Mm-hmm.
Oh, it's just x.
Yeah, because this got canceled out by that.
I'm just still a little confused why it cancels like It didn't cancel out on one side, but it canceled out.
Yeah, because on one side you had the square rooting, and that got canceled out. That one. Okay, now what I want to do, this is review of the first time. So how many of you did corrections? I need to know. How many of you tried to do corrections on that last homework? Okay, I wish more of you would have done it, but here's a little bit of help. This is the lesson you did with the corrections. So this is a quadratic equation now, but remember, I want to get everything to one side and a big fat 0 on the other, and that is not true right now. So what would you do to get 0 on one side, everything else on the other?
I would subtract by x squared.
Okay, I'm going to subtract x squared from both sides. Okay, what's x squared minus x squared? It's 0. So I got that part. But here, writing it in standard form would give me negative x squared plus x plus 6.
No, we don't want that.
But, yeah, what are you guys noticing that's going to be tricky for us to factor? I don't want a negative.
Negative leading.
So,
Negative leading coefficient, it's really hard to deal with. So how do you get rid of that negative 1? You can either multiply everything by negative 1 or divide everything by negative 1, and this is what you end up with. 0 equals x squared minus x minus 6. All the signs changed. But what happened to 0? I thought you had to do to both sides. What's the opposite of 0?
0.
Okay, so you leave it alone.
Ooh, I agree. Yes.
Positive 0.
Ooh. Which one is it? Is it actually possible to do which one is it?
You can subtract 0, you can add 0, so if you want to say that's minus and or plus or minus, I don't know. Anyway, now I can factor it. It's a trinomial here. This is chapter 8. What's my first method to try? Perfect squares. Yes, no, no.
Yeah.
It doesn't work out. So my second method to try is depending on the lead coefficient of 1 or not 1. So we got a 1. You can go directly to this method right here. So you know it's x and x. What two numbers multiply to get me negative 6 that add up to be negative 1?
Minus 3x plus 2.
Minus 3, positive 2. Or negative 3, positive 2. Yep. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. That checks. Okay, do you guys remember that property? When two numbers are multiplied together and they give me 0, one of the numbers has to be 0. So either this number or this number have to equal 0. So either x minus 3 has to equal 0 or x plus 2 has to equal 0. So what would x equal here? If I want to make this a true equation, x would equal 3. I'm going to circle that. What would x be here? And for those who are like, where'd you get that from? Okay, if you're solving for x here, you're adding 3 to both sides. So you get x equals 3. And if you're solving for x here, you're subtracting 2 from both sides, you get x equals negative 2. But those are not necessarily the answers. So you must check them.
In the first one.
I'm going to put in the original one, which means I'm going to erase everything that I kind of added here. Make sure it's all the same. All right, make sure this is the original. Is that the original problem? In your note? Okay. So now I'm going to check both solutions to see if it's really true, because you will get occasionally one or both that do not work. They don't work. All right, let's see 3 if it works. What's 3 plus 6?
9.
Square root of 9?
3.
Does 3 equal 3?
Correct.
That checks. That does work. It's true. So you got 3 plus 6 is 9. Square root of 9 is 3. 3 equals 3. All right, let's check negative 2. What's negative 2 plus 6? 4 square rooted.
2.
Does 2 equal negative 2?
No.
That is not a solution. That's,
No solution.
if that was the only one I could check, it would be no solution. One solution is right here. X equals 3.
So that's our answer? So
Mhm.
we were correct.
You have to check these now.
I got that in my head.
Remember on the first time I made you do this, I said you could check them, and if you do them right, you get a bonus. Okay, these I'm not giving you bonus. You got to check them to get them right or wrong, because you get these two, and you're like, oh, I got my answers. You didn't check them. One of them was wrong. That's a wrong answer. Sometimes they are both wrong.
Can Can we guess?
And sometimes they are both right. So it just depends. Sir?
Can we guess and check? Because that could have been like 1. No, it doesn't work. 2. No, it doesn't work. 3. Oh, it works. I got it right. Yeah, and that would have been quicker than.
Be my guest on it. Well, be my guest. You do it. I'm gonna let you be wise and you do it. See what happens.
Square rooting past like 225.
Yes. Will we have past that? Yeah. But not awkwardly and oddly. It's gonna be like 400 is your most. You're like 400. What's the square root of 400? 20. What's the square root of? Well, make sure I say this. 3.
19.
Yes. And I'm thinking, what's 19 times 9? I think it's 380, 371. Okay. Anyway, don't worry too much about them. They're going to be pretty basic. Okay. Let's do another one. The square root of 3x.
So not when x equals 3 is your
I'm
only.
bugged by that. 361. Man. Yes.
So for that one, x equals 3 is your only answer, not x.
Yes.
Okay.
When you worked it out, you got 2 answers. But when you check it, only one works.
Okay.
One of them is your answer, not both. Okay. This
What
one's
are these?
3x minus 2.
Are these the x-intercepts?
Okay, I was going to get on this next problem, but let's go through it now. Your 2 solutions, or your 1 solution, or your no solutions, which are possible, x equals this, x equals that, or x equals none of those are where that parabola hits the x-axis. They're x-intercepts. You guys ever find x-intercepts? Okay, you can find it using your quadratic equation. I said quadratic equation. Do you know that there are quadratic equations like this one, the last one? And then there's the quadratic formula. It's the ultimate formula for quadratics. It can work out any of the problems you've ever worked out with quadratics. Any of them. Put it in that equation, got it. It's coming. Sorry? It is. Yeah, that's what it is. I mean, it's cool. You're gonna be like, oh, it's very helpful too. All right, here's I'll tell you, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the equation.
I remember that. Okay, I got it.
And you're going to have to memorize it, so get used to it.
Oh, just over 2.
I already memorized it, Mr.
Yeah, all over 2a. All over. Yeah, so it's, I'm going to write it because this is cool.
X over b.
You,
Do the guessing there, see if we can get it right. Yeah.
you may, yeah, that's
Yes, let's go. Okay.
So negative b plus or minus the square root of b squared minus 4ac all over 2a. You're going to have to memorize that eventually. And it looks kind of weird, but
So ironic.
that's what I was talking about. This right here is in that vertex, or sorry, the axis symmetry. And then this right here is in something we call completing the square.
Well, what's a c? Because you only have x squared minus 2,
Oh,
so that's 2
it's about
terms.
circle.
C is your constant. Yeah, it's all part of the ABC standard form. That's
I
later.
guessed and I got it right.
Awesome.
Then I did the problem out and I got it wrong.
That's a problem.
That is a big problem.
All right. I want to do what first? I want to get rid of the square rooting by squaring this right here. They will undo each other by squaring. But what I do to one side, I have to do to the other. I got to do to both sides. You can't just keep it imbalanced. Okay, what am I left with on the left side? 3x minus 2 equals, on the right, x squared. Okay, so I got rid of the square rooting. The problem is now a quadratic, at least officially a quadratic, and then I can go ahead and solve. So how would you guys do this? Get everything on one side, get 0 on the other.
Are the numbers usually going to be lower when you get your answer? Because
Not always. Yeah, because I'm telling you, you guys are trying 1, 2,
Well, I
okay.
just-
It works, but then it doesn't. And that's sad.
That'd be 3x. Oh, wait, never mind.
That's okay. Yeah, and you're like, none of these are like terms, so you just rewrite them, standard form.
Yeah, don't you just rewrite it without the square root? When you
Yeah, when you get rid of them, yes. But you need to show me your squaring because that changes up when it gets more complicated. Okay, listen carefully. I have this right here, but is this factorable as it is?
No, it's not.
Change all the
Signs.
so I get x squared plus 3x minus 2 equals 0.
Mr. A, I like 0 being on the left.
Yeah, either way. You can do either way. All right, what's the factor in here?
X times X.
Yep, x times x, good. So what two number, and okay, here's the process. It's a trinomial. You try perfect square trinomials. You got a yes, no, no. You're done with that. So then you have a lead coefficient of 1. You don't do bridge. You just go straight into the binomials. What two numbers?
It's positive 2,
Wait,
negative
one
2.
negative
Yeah, it's positive.
Wait, is
Yeah,
it
yeah,
negative
positive
3?
2,
Wait,
negative
yeah,
three.
why
Wait,
negative
it's negative 3.
I don't know. I'm sorry. Yes. I apologize.
Positive 2, negative 3.
I don't know how I did that. Okay, so this is positive, this is negative, and this is positive.
It's negative 2 and negative 1.
If you've guessed, you may have gone 2 for 2. You want to keep playing those?
No, guessing is hard because I got 2 and I forgot to use 1. So then, like, I could have gotten it wrong.
Yeah, and really, guys, it does get more complicated. Hopefully, you can do these, and yes, change your signs as I did not. Okay, what are the two factors that multiply to give me 2 to be negative 3?
X minus 1.
Okay, minus 2, minus 1, doesn't matter which one comes first. All right, what's negative 2 times negative 1? 2. What's negative 2 plus negative 1? Negative 3. All right, so we got the right numbers. So what does x equal?
2 and 1.
X equals 2 or x equals 1. Good, and we said maybe because we're not sure until we check them.
Yeah, pretty sure. Well, I did check it. We're checking it right now.
Wait, Mr. Ed, can they both work?
Yes, they could both work. One of them can work or none of them can work. Okay, what's 3? Shh. I remember I hear a lot of comments, and that's good. You guys are interacting, but at the same time it's distracting, so hold them. 3 times 2. 6 minus 2. Square root of 4. Does 2 equal 2?
Correct.
So that one works.
Because, okay, so you get 6 minus 2.
It's 4.
Why did you get a square root? That's what I did.
Okay, let's try 1. What's 3 times 1?
3,
3 minus 2.
1,
Square root of 1.
4.
Does 1 equal 1? So they both work. They're both correct. So that means this graph is a parabola, and it... No, we're not going to graph it. Now you know that it hits the x-axis at 2 and 1. And that would make it a pretty skinny graph. Okay. Okay, next one I'm going to give you to do on your own.
Let's go. Can we try that? Yes.
Yeah, just do whatever to figure it out, and good luck.
I don't like it.
No, not yet.
I give the big one so you can't guess.
No.
Oh, it's plus 14. Plus
I don't
14.
think I'll be able to. I mean, guess it. Oh, I think I can. It's got to be negative, fam. It's negative 5. Got it. Shh. It's not. I'm just kidding.
Good.
Mr. A, we've gotten so much better at that.
You have. I've noticed that. Even those who struggled at the beginning of last year or this year have gotten better, but I want you to keep trying. That's all I don't want you to get perfect scores. I don't want perfect homework grades. I want effort. Effort is going to make up for all that stuff. Mr. A, I'm not good at math. Neither am I if I didn't practice. And that's the basic thing of math. I'm not good because I'm somehow mathy. No, my wife is way more mathy than I am. But the reason I know more is because I do more. So I just practice it more. But she would probably teach you better. Okay, so don't record that. Erase number at 20 minutes, 8 seconds. I love my wife. Okay, anyway, so the thing is, she may know stuff because she's naturally gifted at it, but because I keep practicing, I get better. We want to keep it that way for now. Yeah.
I'm thinking of it. Is there a way that a negative could work?
Yeah. There. In this case, probably not, because if this were a negative, that can't be a negative, so it won't work. But it could. If you had something else here.
But if you don't have anything there, the negatives can't be.
Pretty much not.
Okay.
Pretty much. Okay. I'm going to work it out here. You may have done it the same, may have done it differently.
I didn't do that. I did the way where you just guess and check, and I did I did 2, 3, 4, and 7. And then I got it.
Awesome.
It's really not that hard if you just multiply numbers and add in your head.
And don't you go to the side?
Good. I make sure I switch them.
Can you solve with that number negative right there? The x squared is negative?
You could, it's just the factor gets a little like jumbled.
Yeah, and
Negative 7, positive 2, x equals 7. No, we're not done. Alright, I think it's this one, I think it's that one, but it's not that one.
So when you do 5 times
Why is it not negative 2?
because negative 2.
Why is it not? What did you get when you put negative 2 here? What's 5 times negative 2?
10 plus 14.
Negative 10 plus 14 is 4. Square root of 4 is 2. And 2 does not equal negative 2. Okay, but 7 does work. All right, let's move on to the next type of problem. Okay, it does get a little bit tougher. All of these have had factoring where the lead coefficient is 1. What if the lead coefficient is not 1? This is what we do. 7. 7 is the only one that works.
I did 7 and I didn't. I got. Wait, so you do 5 times 7 plus 14 equals 4. I just worked it out.
Good. You talked it through, Marissa, and I was kind of listening. But I thought you could figure it out. And you got it. Okay, go ahead and do this one. The reason this one's different is because it's not just x on one side, it's 3x, which means something.
3 off of all of them?
No, because if you divide by 3, let's say,
Or could you just subtract?
if you subtract it, you're just going to get this.
Oh, yeah. But then it would be. Could you?
If you divide by 3, you get this. So it's not helping you out. So here what I'm going to do is the same thing I did last time. You see I'm just doing the same thing? I'm going to square both sides. What happens here? I'm left with 4 minus 9x equals. Right here, sorry. 4 minus 9x. What's 3x squared? 9x squared. 3x times 3x is 9x squared. So then what do? Get everything on one side, get 0 on the other. Same thing I did before.
You just made your life harder without being the same. For no reason.
Say that again? Yeah, we're going to make it insane. We have to make it factorable. Make sure I get my signs. All I did was rewrite it. So this negative, negative, positive, and then I change all the signs, and I should get 9x squared plus 9x minus 4 equals 0. I don't hear very much from those mental mathers. You notice this one's a little tougher?
It's not.
You could waste your time thinking it, or we're just constantly doing the same thing and we're getting better at it. Boom, 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 boom.
I know it. No, wait. Shoot.
That's a 50-50 and you did well. Or did you?
Oh, wait.
I don't know.
Isn't that make
What's 9 times negative 4?
It's nothing.
Negative 36. Okay, sorry.
Yes, I agree with that. Because if you put a negative in this one, it makes this one positive and that one negative.
Okay, hold on, guys. Let's go here and then we'll test that.
Can't it just be 0?
It could be. Okay. What are the two factors of negative 36 to add up to be 9? I'm doing the bridge because
Is that possible?
Negative 12.
negative 3 to 12. Yep. So I'm going to erase that negative 36 because you might get blended into the worth. So 9x squared plus 12x minus 3x minus 4 equals 0. And then you're going to do your factor by grouping. What's the GCF of the first two? 3x. And then you're left with 3x plus 4 for the first factoring. And then the second factoring, what's the GCF? Negative 1. You're left with 3x plus 4. I'm thankful for that. What's the GCF of those two? 3x plus 4. What's left behind? 3x minus 1. And that equals 0.
Oh, I forgot.
See, and listen to me very carefully. This is for all the mental mathers. You didn't practice the other 2 times, you don't know what to do this time.
No, but we didn't have this one the other time.
We did. It's the same thing.
No, we didn't
A lot of
It's
these
the
things
same
going
Yeah,
variable
the,
is not 1.
Yeah, the variable was 1 in this one.
But what I'm saying is that everyone else who did it again, they have a better idea what to do now.
I
Because they
didn't
did
do
it
the math
again.
last time. I've written down every single problem.
John's getting so defensive.
That's okay.
I still don't know.
What I'm trying to help you guys out, do
I know that.
it the way that you can always get. Like sometimes you can pull it out in your head, and that's good. That's like a good skill, but you want to always practice this method. It's like I could sometimes do a behind the back shot. I've done 1 or 2 in my lifetime, but I'm not doing that in the game. Like whoa, whoa. I won't.
Yeah, they're all the girls' basketball team did.
Who? Danny. Really?
And now she's
When
gonna
you
shoot
look
those
at-
from now on.
Yeah.
I got both fractions. So
Okay. Yep. 2 fractions, right?
So
I got x equals negative 4/3.
yeah.
Ouch.
And
That's
I also got
not a nice fraction.
No, wait,
x
Mr. Ray,
equals
couldn't
1/3.
Okay.
Sorry, Sarah's talking.
Okay.
And
Yeah.
x equals
X equals 1/3.
and x equals 1/3.
So I
That's correct.
checked 1/3 first.
Good.
And so I did 4 minus 9. That was negative
Hold,
5.
can I? I'm gonna check with everyone and see if you ours check. Okay, you should have gotten these 2 answers, and you're like, you got it, kid. We gotta check this, guys. The checking is not that bad. Yes, they're fractions, but they are not that bad. I'm gonna erase all this work. Does anyone still need it? Some of you aren't even working it out, and you're wondering why you don't get this stuff. Wonder no longer. Okay. The original problem was 4 minus 9. I'll check 1/3 first too. Times 1/3 equals 3 times 1/3. That's the original problem. So I'm putting in 1/3 in here, and you're like, can I even do that? What's 9 times 1/3?
3.
It's 3. So what's 4 minus 3? 1. What's the square root of 1? 1. And you're like, but then you got to do that. 3 times 1/3 is 3/3. 3 divided by 3. 1.
So
Okay,
if you did
check.
4 minus 9 first, that'd be wrong, right?
So anything but a fraction would work.
No.
Would
no.
not work.
Anything.
Anything that's not a fraction would not work on this problem. Because if you put negative in this side, then you get this side positive and this side negative. If you put positive on that side, you get this side negative.
I'm going to do the swivel. You're on a leash now. Done. Okay.
Is it a coincidence that like if one of your x's is 1/3 and then if you flip it it's 3, which is your value that you get on the outside? It's kind of weird.
The 3, is that a coincidence? That's part of my answer and part of that? No, that's not a coincidence. It's part of the, there's something going on there. All right, what's negative? What's a negative times a negative? Positive. 9/3, 3. 3 times 4, 12. 12 plus 4, 16. Square root of 16, 4. 3 times, oh.
It's negative. It doesn't matter.
Oh yeah, that. Doesn't work, not an answer.
So you do the right side first, and if you get negative, it's not possible for the end.
Okay, let's get your, I'm sorry, I'm gonna give you. Do you want your homework?
Yeah, we have some. Thank you, Mr. Ryan.
Did I erase?
Whoa.
Okay.
I already know.
It's 34 to 34, no, 34 to
34, sorry.
It's okay.
That would have been good.
Yeah, I'll take the report very
How do you
quick.
multiply a fraction down?
Yeah, let me do that again. I'll show you here.
Oh, that's nothing.
Okay. Fractions like I think you had 4 minus 9 times 1/3. Okay, let's just do that part. Okay, when I'm multiplying these two, this is 9 over 1. Okay, multiplying and dividing, you're dealing with numerator and denominator, and you don't have to get a common. But do you remember, is there something in the numerator and denominator that cancels? So 3 goes into 9, 3 goes into 1. Sorry, 3 goes into 3 once, 3 goes into 9 3 times. So then you just multiply across. What's 3 times 1? And 1 times 1? So you just leave it 3, and it's negative. So you do like that. Then I got my 1. Then I got my 1. All right, the other side I think was 3. Oh, the other fraction?
Yeah.
That's fine, we can do that. I got you.
Aren't you a gentleman?